right, so here we are on the applications portion of the Unit 2 Algebra 2 test. So this is only for the pre-governor student. All right, number 36. We have a small stone is thrown into still water, which creates a circular ripple. The radius r of the ripple increases at a rate of 2 centimeters per second. So we've got a little circle here, and this is our radius r, and it's spreading out like a ripple in the water. We're supposed to write a function r of t for the radius of the ripple as a function of time t in seconds. Looks like I wrote sentence twice, sorry. So what's r of t? Well, at time 0, we had a radius of 0. If we're increasing at a rate of 2 centimeters per second, at time 1 we would be 2 centimeters big, then the next second we would be 4 centimeters big. So basically I'm taking 2 centimeters per second times the number of seconds, and that's going to give me my radius. All right, number B says write a function for the area of a circle, A of r, in terms of its radius r in centimeters. So this is just any old generic circle. The radius of a circle, if we plug it into the area formula, we have pi r squared. So this has nothing to do with our ripple, it's just any general circle. The area of a circle in terms of its radius is pi r squared. So now it says if A of r is the area of the water within the ripple, so we're taking our little ripple and filling it in, so we have an area. What is A of r of t? So into my A function, I'm going to plug in my r of t function. Well, my r of t function was up here. My r of t function is 2t. So into my A function, my pi r squared, instead of plugging in r, I'm going to plug in 2t. That should probably be simplified a little bit. So I'm going to rewrite this as A of r of t. That's equal, if I square my 2t, 2 squared is 4. The pi still is a pi, and then I have t squared. So that's my area function based on the time. It says find A of r of 10 and explain what it represents in real life. So if we're doing A of r of 10, we're really starting out, we're figuring out what r of 10 is. So what's the radius after 10 seconds? So that would be 20. And then we're plugging that into our area formula, and we are doing pi r squared to it. So we can either go through and plug first into the blue one and then the red one, or we could plug into our new function. It doesn't really matter. We found our new function would be A of r of t, where t is 10. And I'm going to plug in, that's 4 pi times 10 squared. So if I square my 10, that gives me 100. So my answer is 400 pi. I want to include units with this. So my area would be in terms of square centimeters. And this means, I don't have a lot of space here. I'll write it up here. Okay. At t equals 10 seconds, the area is 400 pi square centimeters. That's the real life implication of A of r of 10 is equal to 400 pi. All right, so now I've got a different situation here. I have r and the little negative one in the exponent. Remember that means inverse. This says find r inverse of 8 and explain what it represents in real life. Well, what is r inverse? R inverse is the opposite of the original function. So if my original radius function was r equals 2t, then in my inverse function, t equals 2r. I switch r and t. Now I'd have to get my new r by itself. So I would have r is t over 2, and that's my inverse r. So this one's a little bit backwards. If I'm plugging in 8 to this one, I have 8 over 2, which gives me 4. So what does this mean? In my original function, the number I plugged in was the time. So in my answer function, my inverse function, the answer is the time. And my input is the radius, which used to be my y value. So what this inverse function is telling me is when the radius is 8, and that would be centimeters, the time is 4 seconds. So we've switched our input and output. If in my original function I plugged in 4 seconds, I'd get out 8 centimeters. In my inverse function, I plug in 8 centimeters and I get out 4 seconds. Okay, number 37. On this one, you make an online purchase from soccer.com for new jerseys. Each jersey costs $14.95. You also want to apply a team logo for a $10 fee per jersey. Then you also have a coupon code for 20% off. So we got a lot of things going on here. We're going to have some sort of composition. Let's work it out. It says write a function c of x for the total after the coupon. So we're not going to worry about the logo, no logo, on the number of jerseys. So what would we do to figure out the cost? Well, first of all, we have to buy the jersey, and then we've got to get 20% off of it, right? So our jerseys were $14.95 each. So that's $14.95 per X, $14.95 for each jersey. So this X over here was the number of jerseys, right? And then after that, we have to take our coupon code, which is 20% off. So when I do 20% off, you can either find 20% and subtract it. What I usually do is I multiply by 0.8, which is 80%, because if you're subtracting 20%, you're keeping 80%. Okay, so to do this, I would go ahead and use my calculator. Let me put one up here. Sorry, it's right in the middle. I have, clear that out of there, I have $14.95 times 0.8, which gives me $11.96 per jersey. So that's my function, c of x equals $11.95 per jersey. Sorry, I just realized I said that wrong. It was $11.96 per jersey when I look back at my calculator, $11.96 per x. All right, now in part B, they want us to write a function a of x, where a of x is the total with the logo application. Now there's no coupon on this one, and it's based on the number of jerseys x. So I'm still plugging in my number of jerseys. What do I do for each jersey? Well, it's $10 per jersey, so my logo fee is just 10x. A of x equals 10x. All right, now it says to calculate and interpret c of a of x and a of c of x and determine which one results in a lower cost to you and why. So let's do that. Let's start out with c of a of x. Oops, get my red pen here. So c of a of x means I'm going to take my c of x function, which was $11.96 per x, but instead of plugging in x, I'm going to plug in a, which was 10x. So what happens when I do this? $11.96 times 10x is what? $119.60 per x. So what does that mean? Okay, so what would this mean? This up here would mean that we were charging $119.60 per jersey. Does that make sense? No, something's wrong with that one. The composition there doesn't make sense for this situation. Let's go to the next composition and see if that one makes sense. If I do a of c of x, Well, I'm going to start with my outside function, my a of x. In this case, my a was take 10 times my x. What am I plugging into there? Instead of plugging in x, I'm plugging in my 1196 times x. So what happens when I do this? I multiply it out, and I still get 119.6x. So in terms of which of these results in a lower cost to you and why, this is really neither. Neither one of these right now is making sense. If I wanted to find my cost of my jersey using a combination of different functions, that's what I'm going to do here in Part D. So let's just go down and read that. Unfortunately, the coupon code does not apply to the logo fee. Find your total bill for a purchase of 8 jerseys and represent this value in function notation. So if I'm going to buy 8 jerseys, I've got my coupon code, and I have to pay my logos, but I have to pay them separately. What am I going to do? I'm going to find my cost of my 8 jerseys with my coupon code at $11.96 per jersey. What does that make this? Hold on. So if I multiply those together, that's making my jerseys cost $95.68. So over here, $95.68. That's for the cost of the jerseys. Now I need to find the cost of the logos. Well, if I'm buying 8 logos at $10 a piece, then the cost of my logos is $80. Am I going to plug either of these functions into each other? No, I'm not. What I'm going to do is I'm going to add these functions together. I want to buy my jerseys, 8 jerseys, and then I want to buy my 8 logos. So I put those two things together. $95.68 plus $80 is $175.68. So in function notation, I can either write it as C of 8 plus A of 8, or I could write it as C plus A of 8 is 175.68. Okay, thanks. Be sure you think about these applications. They should make sense, and sometimes I'll ask you to do things that don't make sense, and you got to realize which ones do and which ones don't. Okay, come into class with any questions. Thanks.